So then the question arises, what makes a good kernel? Well, obviously a very successful major. That was a joke. So let's consider a uniform filter. Did you get that one, Megan? Yes, you got it. Good. All right, so remember the averaging filter, right? So the averaging filter was just this box filter of all 1/9, and as we moved it around, we took this image on the left and we created this image on the right. All right, so the question naturally arises, what if I had some image like this and I apply that box filter? What would I get? Well, I would get this, and that is known as really, really ugly. Okay, that does not look, at least not to me, as a nice smooth version of the original. Now, if you're looking at an itty bitty monitor, it might look nice, but trust me, it's really ugly. And the question is, what went wrong? Well, really what went wrong is squares are not smooth, which is probably a statement from the 60s, but it's what I mean. Basically, filtering with something that's not smooth to try to think about blurring or filtering an image to make it smoother doesn't seem right. And in fact, we'll be able to say a lot more about what smooth means in terms of the mathematics in a few more lectures when we talk about Fourier analysis. So what was the problem? To get a sense of what's wrong, imagine that you had a single point of light that you were looking at very far away, right? And you blurred the camera so it was out of focus. What would the image look like? Well, it would look something like that, okay? Brighter in the middle, falling off towards blackness at the edges. Very, very deep, all right? And in fact, if we think of images as functions, I could take this image and I could plot it as this function. If I plotted that blurry spot, what kind of function would I get? Well, it would look something like here on the right.